Hi, it's Mr. T here with a quiz on reaction rate. There's just 12 questions in this quiz and you're looking to get 11 or 12 to be an A+. This can be really useful if you're studying level 2 NCEA Achievement Standard 91166 or just to see how your general chemistry knowledge is. Okay, let's get on with it. Which of the following changes will not affect the reaction rate of Mentos with Coke? Increasing the surface area of the Mentos, using a larger bottle of Coke, or increasing the temperature of the Coke, or using a flat bottle of Coke. So again, you increase the surface area of the Mentos, use a larger bottle, increase the temperature, or use a flat bottle of Coke, which will not affect the rate of reaction. So using a larger bottle will not affect, it's just more of the substance, but it's not changing the surface area, the concentration, the temperature, or a catalyst. Why does the reaction of glycerol with permanganate on the right petri dish here react faster? Is it because the glycerol was added at a different temperature, or that the permanganate has a larger surface area on the right, or the glycerol added was a different concentration, or there was a catalyst added to the sample on the right? One of those four, which one? The correct answer was the sample on the right had a larger surface area. It was ground into smaller pieces, so it reacted more quickly. What is added to make this reaction happen so fast? Is it activation energy, more reactant, more product, or a catalyst?
3, 2, 1, 4. There we go.
This reaction happens quickly because it has a catalyst potassium iodide added to it, and it's called elephant's toothpaste. What is missing? What is the missing label, X, from the graph below? Is it enthalpy, energy hump, activation energy, or catalyst? The correct answer here is the activation energy, and that is the wee hill that we see happening in this reaction diagram. What type of energy do reactants need in order to overcome the activation energy? Is it kinetic energy, chemical potential energy, gravitational energy, or nuclear energy? The correct answer here is kinetic energy. The particles need a sufficient amount of kinetic energy to overcome the activation energy. What does the red dotted line on this graph represent? Is it the reaction path when the temperature is increased? Is it the reaction path when the concentration is increased? Is it an alternative reaction pathway, or less reactants being added? What does the red dotted line represent in the graph below? And the red dotted line, of course, represents the alternative pathway that is produced when a catalyst lowers the activation energy. What does not happen when the temperature of a reaction is increased? The particles will have more kinetic energy, there will be more frequent collisions per second, the reacting particles will move faster, or the particles will collide less frequently. The first three statements were correct. What doesn't happen is the particles do not collide less frequently, they collide more frequently because they have more kinetic energy. What happens when the concentration of a reactant is increased? What happens to the reaction rate? The particles will have more kinetic energy, the particles will collide more frequently, the reactant particles will move faster, or the particles collide less frequently. If the concentration of one of the reactants is increased, there will be more frequent particle collisions. What will not happen when a catalyst is added to a reaction? The particles will have more kinetic energy, the particles will collide more frequently, the reacting particles will move faster, or there will be more frequent successful collisions. So in this case, a catalyst will ensure that there will be more frequent successful collisions by providing an alternative reaction pathway. What observation cannot be used to measure the rate of a reaction? The volume of gas released against time, the amount of product produced, the change in mass against time, or the change in color intensity against time. Of course, the amount of product produced is determined by the amount of reactants that were reacted, not their concentration, their temperature, or their surface area. So that is the one factor that will not increase the rate of a reaction or influence it. What is being observed in this experiment to measure the reaction rate change? Is it the change in mass, the change in pH, the gas released, or color change? Of course, this is the disappearing cross experiment, and what we're seeing is the intensity of the change in the intensity of the color, and we observe that by whether we can see the cross at the bottom of the beaker or not as the reaction progresses. When bakers place bread in a warm place to rise, they are adding a catalyst, increasing the temperature, increasing the concentration, or increasing the surface area. Of course, in this case, what bakers are doing is they're increasing the temperature. That will make the particles move, have more kinetic energy. They will collide more frequently, and because they have more kinetic energy, more of their collisions will be successful as well. And that increases the rate of carbon dioxide produced, and therefore the rate that the bread expands. Okay, so how many of these questions did you get right? Did you guess more than 11? Are you an A+, or have you got a bit more work to do? Look, I hope this video has helped you just pick up some of the key ideas and reaction rates, and look out for other videos that I've made going over different chemistry ideas, and make sure you subscribe and like. Thanks very much.